Hello there. Okay, welcome back. What I want to do is to continue with electrons charge. Okay, so what I'm going to look at is electrons and charge, and this will be session 2. Okay, now I've done session 1 already, and this will be session 2. Okay, now again, you're not going to see what I see at the moment, so you will need to look at electron charge 2. That will be the video that you'll need to look at in regards to this. Okay, now it's okay. I'm just looking at my screen at the moment, and it looks a bit darkish. Okay, all right. Let's get to work. Okay, let's see what I can do with this one. Okay. Sorry. Okay. 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 Oh. It's okay. I'm always having to rearrange getting the camera into the right position. But you can, and when you think you've got it in the right position to start, it then something simple takes it out of place. Okay, so what I'm going to be looking at is again sitting gills. Okay, and I'm going to leave it overall broad. Okay, and we're looking at electrons and charge session 2. Okay, electrons and charge session 2. Okay. Okay, I'm hoping that will be it. Okay. Now here we are looking at review of basic scientific concepts related to electrotechnology. Okay. Now EMF, and we've covered a little bit of this already. Electromotive force, or EMF, is the name given to the force which pushes the electricity around a circuit. Current can only flow when there is something to push it around. A battery or cell has an EMF, so do alternators and dynamos. Okay. Okay. Effects of an electric current. There are three effects of an electric current: chemical, magnetic, and heating. Okay. There may be other effects since we have developing other means for heating and so forth. And we're looking at what we call new technology. So keep that in mind. So keep an open mind. You're not limited to this by any means. Okay. Chemical effect. When an electric current passes through an electrolyte, a liquid that allows ions, electrically charged atoms, to move freely across it, it breaks down, and hydrogen ions, positive, are collected at the cathode. Sulfate ions, negative, are collected at the anode. Okay, let me repeat that. When an electric current passes through an electrolyte, and that is what you have in your battery for your car or your motorbike. You have a battery which contains electrolyte, a liquid that allows ions electrically charged atoms. Now, the electrolyte allows electrically charged atoms to occur, to move freely across it. It breaks down and hydrogen ions, positive, are collected at the cathode. So you have your anode and your cathode. Okay. Sulfate ions, negative, are collected at the anode. Okay. The anode and the cathode are just two dissimilar metals. The passing of the current through the electrolyte is called charging. The density of the electrolyte is reduced when a cell gives out a current. The density of the electrolyte is restored when the cell or battery is recharged. The instrument for measuring the level of charge is a hydrometer, and it measures the specific gravity of the electrolyte. And here we have a simple cell. Okay? Cathode, anode. Okay? And you have your container electrolyte, simple cell. If a load is connected between the plates, then the current will flow from the anode to the cathode. Will flow from the anode to the cathode. Okay. Goodness me, I missed my positive sign there. It's okay, I just missed my positive symbol there. The delivery of current to the load is called charging. Types of cell. Batteries are a collection of cells. There are two types of cell in general use. Primary, which is only used once and cannot be recharged. Secondary, which can be recharged. There are two types of secondary cells, lead acid and alkaline. Now, bear in mind there could be more types of secondary cells these days as we're looking towards environmental changes. Okay, so take that into account. Keep an open mind in regards to this, because we have got now solar panels and so forth, and that is a type of cell. Here we have the secondary cells. Okay, positive terminal separators holds the plates in position. Okay, negative terminal. Okay. The energy supplied from a cell is sufficient only for a limited time, as the chemical qualities of electrolyte deteriorate with use. When batteries are being charged, hydrogen is given off, and care must be taken to avoid explosions. Here we have alkaline cells. There are two types of alkaline cells in use, nickel iron and nickel cadmium. Both are housed in a metal case, and the electrolyte is caustic potash. Now that's a kind of paste, if I remember correctly, but I could be wrong, so don't hold me to it. The plates are separated by insulated rods and mounted in non-metallic crates to insulate the cell from each other. Advantages of an alkaline battery: strong and can withstand vibration, can be left in any state of charge for long periods, can stand overload without damaging plates, etc. Disadvantage: costlier than lead acid. the magnetic effects of an electric current, and here we have, all we're showing you is the effects, direction of current flow, okay? And this is the current going away from you, basically, okay? Magnetic fields, same thing here. This is just a transformer core showing you the transformer, the magnetic flux around that lamination, okay? And this would be a step down transformer. When an electric current passes through a conductor, a magnetic field appears around it. The magnetic field increases when the wire is formed into a coil. If the coil is wound on an iron core, the iron will become magnetized, okay? Heating effects. Now, when current passes through a conductor, there is resistance to that flow of current. The combination of resistance and current flow produces heat. So here we have dissimilar metals, a bimetallic strip, okay? And these are used for thermostats. And here we have something called microvolts, leads to voltmeter, must be made of identical material, thermocouple. As the heats up, dissimilar metal expands and produces a current, and produces a small voltage, which is you can control to control your heating in your oven. Okay. Okay, I hope you found this useful. Have a good day. Bye bye for now. Okay, thank you. I hope you found that useful, and look at the video. Okay, that goes with it. Of course, you wouldn't have been able to see what I'm saying, looking at overall. Okay, but in doing that and saying that, we hope that you found it useful. Have a good day. Bye bye.